All right, so we are going to finish up 20-3 today. We have looked at multiplying radicals last week, and today we're going to look at dividing radicals. Um, so just to kind of review from last week, when we multiply radicals, what do we do with our like terms? We group them, right? So all the numbers get grouped together, and all of the same variables, all the x's get grouped together. And then what happens to your exponents with all of the, like if you have x squared times x cubed, what do you do with your exponents? You add them together, right? So x squared times x cubed becomes x to the fifth, right? So now you have x times x times x times x times x. And so we looked at grouping everything inside, everything that's inside, as long as the radicals are the same, you can group everything inside square roots and all of that, and then you can group them together and then factor tree them out, right? So now we're going to look at dividing. Now we have looked at dividing before, so when you divide radicals, what do you do with the exponents? Subtract. So now we're going to look at, well, what happens if you have some stuff inside the radical, some stuff outside of the radical, what happens? So the division property of radicals, we have a times the square root of b divided by c times the square root of d. You take your numbers that are outside the radicals and you divide them, and then everything that's inside the square root can be divided inside the square root that has it all inside. And the reason that this is helpful is sometimes it's easier to divide the numbers and then square root it. And sometimes it's not easier. Sometimes it's easier to deal with them individually. But the more you know about radicals, the better prepared you are for dealing with them, because you want to make life easier, right? All right, so the little thing here to divide radical expressions, the index must be the same. Find the quotient of the coefficients and the quotient of the radicands. Simplify the expression. So looking at example B, we want to divide each expression and simplify. So we have the square root of 6 divided by the square root of 2. Well, the square root of 6, that's not a perfect square. Square root of 2 is not a perfect square. So we're going to look at them together. So we have the square root of 6 divided by 2. And then 6 divided by 2 is 3. So now we just have the square root of 3. So if you put this into your calculator and square root of 3 into your calculator, you should get the same value. All right, so B, we have 2 times the square root of 10 divided by 3 times the square root of 2. So here we're going to take our 2 and 3. Those are both outside the radicals. We're going to group those together. And then the 10 and 2, those are both inside a square root. So we're going to put them, instead of having 2 separate square roots, we're going to move them into the same house. And then we can divide those. And 10 divided by 2, that's helpful to divide because that's a nice 5. So this mass is the same as 2/3 times the square root of 5. Questions so far? It's not too bad, right? We've done worse, right? Alright, so C is going to be the same process, but now we have a letter in there. So we're going to look at the numbers outside. So we have 8 and 2. So that's where that 8 and 2. We're going to divide those. 8 divided by 2 is how much? 4. So that's where that 4 is coming from. This is the square root in the numerator, and we have a square root in the denominator. So then that everything that's inside the square roots we can combine together. So we have 44. Yep. So then we have 24x squared divided by 3. 24 divided by 3 is 8. And then we have x squared. So we bring that along. So now they're factor treeing 8 out. So that's 4 times 2. And so this step is the same as 2 times 2. And then x squared, factor train, that's x times x. Now when we're dealing with the square root, how many do we need on the inside to make one on the outside? 2. So I'm going to put them in groups of 2. So these 2 2's on the inside make how many 2's on the outside? 1. I have 2 x's here. Those 2 x's on the inside make how many x's on the outside? 1. So now I have my original 4 on the outside times my 2 and my x, and then I have this 2 left on the inside. It doesn't have any pairs, so it has to stay there. So 2 times 4 is 8 times our x and square root of 2. How are we feeling? Fine, how are you feeling? Let's try A. We'll do A together, and then I'll have you guys do one on your own. Alright, so in A, we want to divide each expression and simplify. So in A, what are we going to do with the numbers that are outside of our radical? We're going to divide them. So we have 4 in the numerator, 5 in the denominator, and we're just going to make those into their own special little fractions. So 4/5. Now in our numerator, we have square root of 42. In the denominator, we have square root of 6. They both live inside square roots, right? So we can move them in together. So now we're going to have one big square root with 42 divided by 6. Now, does 42 divide by 6? Yes, what is 42 divided by 6? 7. So this inside here can reduce to just 7. Now this 7, can I create a nice factor tree? No, it's just 1 times 7, right? It's a prime number. So then this is our answer. 4/5 times the square root of 7. And if we enter this into our calculator, it should be the same as if we entered 4 times the square root of 42 divided by 5 times the square root of 6. Alright, how are we feeling? Ready to try one with the person next to you? Alright. So I would like for you to try B.
So 10 divided by 2 is 5. So you put the 5 down. 54 divided by 2 is 27. So then you have to do the factor tree of 27. And it's 9 times 3, which is 3 times 3 times 3. And you have to combine your two trees to make one on the outside. So 5 times 3 is 15 is 4 over 3.
Yeah.
Well, yep, that.
Alright, so how did you get the 4? What numbers did you divide to get that?
Those 2.
The 12.3. And then how did you get 25?
Those 2.
Alright, so the square root of 75 is square root of 3 both. So divide those. And 75 divided by 3 is 25. So then how did you get 20? 4 times the square root of 5.
Gotta factor it out and just this number out. get 5 and 5, and that makes nothing in there. And 20 up, that's that.
Okay, thank you. All right, Jerry, you can explain B for Grace. Hi, Grace.
Alright, so 16 divided by 8 gives you 2, but 8 divided by 1 is 8, and then factor that out, that's 2, and then 2 in there. 2 times 2 is 4, x to the 11th power minus x to the 2nd power, x to the 8th power, or 9th power. Distribute that out there, you get x to the 3rd, and then x to the 8th.
Grace appreciates everyone's kindness. All right, so are we all feeling pretty comfortable with these? You know, we all need a little more practice, but you know, it feels approachable now. All right, so the next thing we're going to look at today is rationalizing the denominator. So in math, the denominator is a number that we're dividing by, right? So the problem with square roots is sometimes the numbers are wonky and they're hard to visualize. You know, like dividing something by 3 is easy because we can kind of group it into groups of 3, and it's easy to approximate. But if you're dividing by the square root of 5, that's a little harder to kind of estimate in our head, right? So mathematicians came up with the rule of rationalizing the denominator, and it's a way of making the denominator a non-radical number, so it makes the division of mental math easier. I know in our world, we all have calculators, we have access to computers, and so if you can't do it in your head, it's really easy to bring it up on your phone and put it in, right? But remember, for most of math history, that wasn't the case. Cell phones are a recent thing. So back in ancient Greece, they didn't have that, and so this is a way that they dealt with it. I have my opinions on it, but I'm going to show you how to do it so that you have that information. So sometimes it's helpful, sometimes it's less helpful. It kind of just depends on what problem you're solving and what you're really doing with your answer afterwards. In calculus, sometimes you don't have to rationalize the denominator because it kind of, as you work through the problem, it deals with itself. Other times, it is super important to rationalize it because it makes the math later easier. So it's one of those tools. It's better to have it and know how to do it. So when you need to, you can. But it's not going to kill you if you learn how to do it and then never use it. Okay. So rationalizing the denominator.
Mrs. Freeland, could you please go to the computer lab? Mrs. Freeland, to the computer lab. Thank you.
So here we're dealing with square roots. We have square root of A divided by square root of B. When we're rationalizing it, what we want to do is we don't want to change the value of it. We just want to change how it looks. So we want to get rid of that square root of B. So what we're going to do is we're going to multiply the top and bottom by square root of B. So it's like multiplying by 1. So we're not changing the value, right? But what this does is, what's the square root of B times the square root of B? Square root of B squared, right? And what does a square root and an exponent, when they have the same value, when it's a square root and a square, they cancel each other out. So what is the square root of B squared? Well, it's just B. And then this is the square root of A and B, so they can move in together. And so now you have this number. So what this does is, this is much easier to divide mentally to get an estimation versus this value here. So let's kind of look through this. So rationalizing the denominator, we have the square root of 5 divided by square root of 3. We want to multiply the numerator by the denominator. So we have square root of 5 divided by square root of 3. So we're going to multiply top and bottom by square root of 3. So it's like multiplying by 1. So we're not changing its value. It's kind of like it's changing its output. You're changing how it looks, but not what it represents. So square root of 3 times square root of 3 is square root of 9. And square root of 5 times square root of 3 is square root of 15. The square root of 9 is 3. And the square root of 15, we're just going to let that be. So now we have the square root of 15 divided by 3. So now we know that that top value, we're grouping it into thirds. And so it's easier to estimate. So if I was doing this, let's say the answer is somewhere right around, 1 1/3. The square root of 15 is pretty close to square root of 16, which is 4. And we're taking something that's almost 4 and grouping it into thirds. Does that make sense? Alright, so the look of excitement is just too much. So let's do A. So we have the square root of 11 divided by square root of 6. Alright, so what's in the denominator? Square root of 6, so we're going to multiply top and bottom by square root of 6. So we're essentially multiplying by 1. So we're not changing the value. We're just going to change its output. Alright, so square root of 6 times square root of 6. They're both square roots, so they can move in together. So that's 36. 11 times 6 is 66. Square root of 36 is how much? 6. Alright, I'm looking at that 66. Let's see if we can, it's not going to go any further because 11 is prime. So we have square root of 66 divided by 6. So in my head, 66 is a little more than 64, right? Square root of 64 is 8. So I'm taking something a little bit more than 8 and dividing it into 6 parts. So something a little bit bigger than 1. So that makes the math easier to estimate. You guys ready to try? Alright. I'd like for you to do B. Solved. So what are we multiplying the top and bottom by? Square root of 8, right? So the square root of 8 times square root of 8 is square root of 64. So then up top we have 3, and then we have square root of 5 times square root of 8. So they're both inside square roots, so they're going to move in together. And when they move in, how much do they have? They have square root of 40. Square root of 64 is 8. So that's good. Now, how did we get from 40 to 10? Well, can we simplify 40? Yeah, so making your factor tree, we have 5 and 8, and then 8 is 4 and 2, and 4 is 2 and 2. So then we have the square root of 40 becomes 5 times 2 times 2 times 2. So now it's a square root, so we need groups of what? 2. So here I have these two 2's. It's a group of 2, right? So 2 2's on the inside of a square root make how many outside? 1. So now we have 3 times 2, which is 6. And then 5 times 2 is still inside. We can't group it into other groups of 2, right? So they're stuck inside. So that's 10. And then our 8 in the denominator. Alright, so how are we feeling about that? Alright, so let's try, I'll give you 5 minutes to get started on your homework. So your homework will be the practice on page 310, number 9 to 15.